particles, we say there is a force of gravitation. Between Earth and Sun, we say there is a force of gravitation. But when we talk about the Earth, big Earth, and a small body over here, we say on this body there is a force of gravity. That is, one body is massive, very, very massive, like a planet, and over here there is a small body, so we say that there is a force of gravity which is acting on that. Though we can also say that there is a force of gravitation, but generally we use the term the force of gravity. Whatsoever, suppose if we say this is Earth, and this is small body, let's say A, so whatsoever force Earth applies on to this body in this direction, with the same force, this body will pull the Earth up. To every action, there is equal and opposite reaction. Action and reaction, they are always on two different bodies. But because of this force, there is a very, very small acceleration that is almost equal to 0, so we don't consider it. We just say that is what is the acceleration of this. What is the acceleration of this body when it is released from here? Obviously, it shall be accelerating in the downward direction. What is the acceleration of this because of the force of gravity? That is called acceleration due to gravity. Force of gravitation, we can always say that is between the two of them there is a force of gravitation, but generally the force of gravitation is between the similar masses. When we say that one of the body is so huge, big, like a planet, and there is a small body over here, then we say there is a force of gravity acting on it, and when we release it from here, then this starts accelerating in the downward direction. That is called acceleration due to gravity. And the force of gravity, that is the force with which Earth is pulling this mass in the downward direction, that is called weight. For Earth, we denote acceleration due to gravity by G, and that is equal to 9.81 meter per second square at the sea level. If this is equator, if we take this as equator, at the sea level at a latitude of 45 degree, that is with the equatorial plane, this line is making a 45 degree angle, that is latitude is 45 degree, then over here or over here, wherever it is, this over here, when we say that is G is taken as 9.81 meter per second square. So we have force of gravity, we have acceleration due to gravity, we have weight. Weight is the force with which Earth is pulling all the objects towards its center. Earth has a tendency to pull all the objects towards its center. Rather, before Newton gave universal law of gravitation, it was assumed that is natural state of all the objects is on the surface of Earth. The force with which it pulls all the objects towards center is called weight of the body. Mass of the body is constant, but when we say weight of the body, weight is basically a force only, so this is force only. So unit is Newton, and force is equal to m into A, and over here we are saying instead of A, acceleration, we are saying that is acceleration due to gravity. So when we talk about the weight, so weight is equal to mg. Now there is a variation of g. This acceleration due to gravity, when we say this is acceleration due to gravity, so we understand in this chapter that is this varies. This varies with what? That is, if this is Earth, we say this is Earth, if at the surface we have the value as g, as suppose we take it as 9.81 meter per second square. So this value, it changes as we go up the surface. Number one, it changes, and then as we go down the surface, that is deep into Earth when we go, then also it changes. And suppose this is equator and this is moving around its own axis. When it is moving around its own axis, then because of latitude, because it is rotating, then with latitude also, the value of g changes. So if we talk about how the value of g changes, so we have three variations. One is the g changes because of change in height above the surface. It changes because of depth. Third is it depends upon latitude. Let's understand how it changes with height, with depth, and with latitude.